simplify negative 7 over 2 rad 10. And the question is why? Why should we simplify? What exactly is wrong with this? It's not that it's wrong mathematically. It's not that it's even that sloppy looking. It's just that we, as mathematicians, have decided that this is not allowed ever. We're not going to have irrational square roots in the denominator. And by that I mean the square root of 10 is not going to reduce down to anything. It's not like the square root of 4, which would become 2, square root of 16, which would become 4, etc. So we have decided that this is not allowed, and we have to do something, a very useful skill. I'll spell it out here. We rationalize the denominator. That's a sensible name for what we're going to do, because we are going to make the denominator, oh, how shall I say, not sloppy. We're going to rationalize it. Apparently, it's perfectly fine if the sloppy irrational numbers wind up here in the numerator. So how are we basically going to move the radical up here without changing the value of the proportion, of course? So we're going to start with the proportion, negative 7 over 2 rad 10. And we're going to do something to it. We're going to multiply the top by rad 10 and the bottom by rad 10. And at this point, we're thinking, well, doesn't it just cancel out, do something like that, and then we're back where we started? But we're not going to do that step. Instead, we're going to keep it the way it is, and let me write it out. Negative 7 rad 10 over 2, only instead of rad 10 times rad 10, I'll just write 10. Because the square root of 10 times the square root of 10 is just 10. And now we have this thing, 7 rad 10 over 20, because 2 times 10, and we are done. This is simplified. And apparently, we've just decided to agree that this is okay with the irrational number in the numerator, and this, that I circled before, is not. So you can mark it down. Every time you see a radical inside the denominator, you should probably think about how you're going to move it up here, and you're always going to be doing that by multiplying by top and bottom by that same radical, right? So top and bottom is not going to change the value of the fraction as a whole. But then we come down to something like this as a slightly more complex example. Okay, rad 3 plus 1 over 3 plus rad 2. Again, the problem is this. Besides this, it doesn't really look all that bad, but we've decided that we've got to change that, and we've got to figure out a way to move it up here. But you can't just multiply rad 2 on the bottom and rad 2 on the top, because it's not going to simplify anything. In fact, it's just going to make everything worse. As a matter of fact, why don't I just show you what happens when you do that, okay? So this is what we're not going to do. We are not going to say rad 3 plus 1 over 3 plus rad 2 multiplied by rad 2 over rad 2. Because if I now simplify this a little bit, I'm going to get, let's see, I'm going to distribute the rad 2 like that, and it's going to have to be the same thing down on the bottom. So I'm going to get rad 6 plus 1 rad 2 over 3 rad 2 over rad 2 times rad 2, which is just 2. So not only is there still a radical in the denominator, but overall the thing looks even worse than it did before. So this is what we're not going to do, and I'm going to erase it. So we have this case where the radical is being added to something rather than being multiplied as it was up here, and we have a simple solution. It's called multiplying by the, I'll write it out here. In the name of rationalizing the denominator, of course, we're still trying to do that, but we're going to be multiplying by something called the conjugate. And all the conjugate is, for all practical reasons, okay, it looks like this. We're going to take rad 3 plus 1 over 3 plus rad 2. We're going to multiply by 3 minus rad 2 on the top, and 3 minus rad 2 on the bottom. And why we choose to do this is because of what happens. Watch this. So we're going to do the same thing. We're going to distribute. We're going to get 3 rad 3, that part, and then I'm going to have to do 3 into that part, plus 3. And now I have to take the negative 2, and I have to do the same thing. I have to distribute that. So it's going to be negative rad 2 times negative rad 2 times rad 3, which is negative rad 6, and then negative rad 2 plus 1, which is negative rad 2. And on the bottom here, we're going to do the same thing. Let's distribute the 3 into both things. 9 plus 3 rad 2, again with the negative rad 2. We're going to get negative 3 rad 2 minus rad 2 times rad 2, which is 2. Now let's have a look at how else we can write this. What I see here is a 3 rad 2 minus a 3 rad 2, so you know those two things are canceling out to 0. And from the looks of it, that's about all we can write. About the last thing I can say here is I can say this is 3 plus 3 rad 3 minus rad 6 minus rad 2 on the top. I can't combine those terms in any other way. And on the denominator, I have 9 minus 2 left, 7. And believe it or not, I am done. That is simplified, which to me it doesn't look simplified. It actually looks a lot more complicated. But again, according to the rules set forth by the powers that be, this is way better than this because it does not have any square roots or radicals in the denominator. They are all in the numerator.